In this video, we are going to do an example where we count the number of license plates given certain conditions. So the example says that a state's license plates have 3 letters followed by 4 digits. Part A asks how many different plates are possible. So let me put a question mark there. Alright, so we want to count the number of possible license plates. So overall here, we have to choose 3 letters and then 4 digits. So there's 7 stages to this. So I'm going to put a blank space times blank space times blank space times and then 4 spaces at the end for the digits. So so my 3 spaces at the front are for the letters. We're going to put 3 letters here at the front. So each of these can be any of and there are 26 letters. So let's start to fill in those numbers. For the first letter, we have 26 choices. It can be anything from A, B, C, D, all the way up till Z. And then same thing for the second letter. Again, we have 26 choices. Notice that this allows the possibility that we might have repeats. Like we might have picked a B first and a B second. Okay, and then for the third letter, again, 26 choices again. Alright, now let's focus on the last 4 spots. So those, the problem tells us, are going to be digits. So each of these can be any of the, and there are 10 digits, 10 possible digits, because the digits are 0, 1, 2, comma, dot, 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 up until 9. But because we're counting 0 as a digit, there are 10 possible digits. So we'd put a 10 here, and a 10 here, and a 10 here, and a 10 here. Okay, I'm running out of room here a little bit, so I'm going to scooch this up. So if we had to write this out without a calculator, the furthest I would expect you to simplify it is to something like, so 26 times 26 times 26, that's 26 to the 3rd power. And then we have 4 of these 10s getting multiplied, so that would be times 10 to the 4th. If I could use a calculator, and I worked out what this was, this gives me 175,760,000. Yeah, 175,760,000 possibilities. Alright, let's look at part B now of this example. So it tweaks what it says a little bit. Now this asks how many plates are possible if the first letter must be a vowel, and I'm going to assume that we're just talking about the 5 standard vowels. The second and third letters must be the same, and the digit 7 may not be used. So we're still following these conditions where it says 3 letters and followed by 4 digits, but there's just extra conditions now in the problem. So again, I need to think about how many plates. What is the number of plates? And again, we're going to have 7 stages to this, picking each of the 7 entries that make up this license plate. So there's 3rd one, 4th one, 5th one, 6th one, 7th one. So the question tells us that the very first letter must be a vowel. So there's 5 choices here. Any vowel. A, E, I, O, or U. So 5 choices for that spot. And then it tells us that the second and the third letters must be the same. So let's start by choosing the second letter. So the second letter could be any of the 26 letters. So any of the 26 letters. 26 choices there. But now for the third letter, this has to be the same thing that the second letter was. So once the second letter is picked, let me write that better, is letter is picked, we just have one choice for this. It's got to be the same as the second letter. So if the second letter had been a D, the third letter has to be a D. We only have one choice. But if the second letter had been something different, like F, that forces our hand in what we have to let the third letter be. So there's actually just one choice for the third letter once we've picked the second one. And just to convince yourselves that 26 times 1 is right for those two spots. Another way to think about those two spots is because they have to be the same. The second and third spots could be like AA, BB, CC, DD, and so on. And there's 26 such possibilities. And that's what we got by doing 26 times 1 as well. All right, let's focus on these digits at the end. So the question says that the digit 7 may not be used, which means that these can each be any digit except 7. So that means there are still 9 choices of digits for each of those spots. So I'll write 9 times 9 times 9 times 9. I could pick anything except a 7 in each of those spots. So if I multiply these, we get that this equals 5 times 26 times 9 to the 4th. And if I couldn't use a calculator, we would leave it like this. But if I have a calculator to work out what this is, I get 852,930. Whoops, 30. And that is our answer. So in the next video, we're going to do another example practicing counting like this, where we count pin numbers.